my name is Neha Delal. I'm life sciences, and this is my BlueSky proposal. I came up with this idea partially because I'm just really interested in fantasy and magic, and this is actually kind of a scientific application into that. The issue I'm trying to address is scientific mind reading. There have essentially already been numerous studies in which thousands of subjects through numerous takes were asked to see and look at various simple objects, such as an apple or a short, very simple film with not a lot of details. And in doing so, when they were watching these things, fMRI scans of their brains were taken, and then a computer put all these fMRI scans together, and they tried to create a model in which they would actually be able to connect certain visual cues with certain fMRI scans and thus brain patterns. And ultimately, remarkably, the computer model was actually able to predict what the people were seeing at a given time, and to actually be able to produce a real-time depiction of what these individuals were actually seeing. So they were actually able to basically read the mind of the person as they were looking at these visual images. They were also able to show that there is a huge connection between when somebody gets visual cues and then when somebody is trying to think of something. So another study showed that it actually activates the same regions in the brain when you see an apple versus when you think of an apple. So my proposal combines these two ideas into essentially trying to do what the same study did except with thought. So it would potentially bring, again, thousands of subjects, have thousands of takes, whatever, and it would ask these subjects to think about certain simple objects, and then it would try and, again, input all this into the computer, the fMRI scans from when the subjects were thinking about these various objects, and it would try to create a computer model again. And ultimately, hopefully, this computer model would be able to predict what people were thinking of at a certain time. There's obviously going to be a lot of variations between the subjects. There's also going to obviously be slight errors because we don't know exactly whether these simple objects are actually going to have a definitive brain activation pattern. But at the same time, we have seen promising results that this could potentially work. For example, scientists have in the past actually done this with very simple set of objects, such as just numbers or just letters. And then we can also look at brain-machine interfaces. So essentially, these brain-machine interfaces, or BMIs, they've allowed scientists to actually control the movement of prosthetic limbs, for example, or the military is also using them to actually have robots or whatever controlled from a distance. So we can see that if we can do this with actual physical action, it might be it kind of gives proof that we might be able to do it with visual thought as well. And so then this project would have a lot of applications if it actually did work. For example, it would allow us to actually potentially, well, first of all, there's the fun fantasy aspect. You'll be able to read minds. But then also it has some security applications. For example, it might allow us to actually, when we're questioning suspects, for example, it would give us a better idea of what they're actually thinking. And then it also might apply to dreams. We might be able to actually see what people are dreaming, because that should be pretty similar to what they're actually thinking when they're conscious. So essentially, this project does have a lot of applications, and it would be really cool, albeit difficult, to actually get it done. LS1a told us a lot about these molecules, what's happening all over the body. And so the fMRI scans, they're built upon these simple principles that we did learn in LS1a. So essentially what happens is that every time we get some kind of cue from our environment, a barrage of neural impulses, they flood our brain, they bring glucose, etc. with them. And these fMRI scans, what they do is they look at the difference in the oxygen levels when we get these cues, and then they're able to read that in the brain, and they're able to get kind of an idea of what areas are being activated.